Hi everyone. In the last video, we talked about Little's Law, which is a queuing theory that helps us understand the relationship between throughput, VIP, and response time. This theory also provides us with a fundamental perception of lean methodology, which is based on the study of material and information flows to make an informative operational decision. However, it would be more complex when dealing with a real case. In a real process, any node along the process could be a bottleneck for some reason, which creates ad hoc tasks for a decision maker to manage and ends up with endless firefighter jobs because you will never know what the next problem would be and when. Therefore, you would require a tool that enables you to focus on a couple of crucial and manageable points to make the process run smoothly, as predicted. The tool I recommend is Efficient. I believe that many managers have intuitively adopted it to quickly fix the business problems they face, particularly in a continuous production environment or project management. Let's cut to the chase and explore the theory of constraints. TOC, as a management philosophy, all starts with a book, The Goal, which uses a novelistic approach to describe how a factory manager, Alex Rogo, on the brink of bankruptcy, revived the factory with the help of a business management expert. The author, Goldratt, had already developed optimized production technology and its accompanying software by the late 1970s. However, it wasn't until 1984 that TOC became a manufacturing concept for the first time through this book. Over the subsequent years, it gradually evolved into a mature theoretical framework encompassing operational strategy toolkits, performance measurement systems, and thinking process toolkits. TOC reveals factors that drive a system toward its goals are not all of the system's resources but only specific individual resources known as bottlenecks. The theory of constraints holds that nothing within a system exists in isolation, and the behavior of an organization changes due to internal or external influences. Despite numerous interconnected causes, the most critical factor always exists. Identifying and addressing the critical factors constraining the system leads to a disproportionate increase in effectiveness. In the second part of the video, I will introduce how TOC defines the goals and the DBR approach followed by 9 principles. TOC breaks away from traditional accounting cost concepts to measure the performance and effectiveness of achieving goals and proposes 3 main performance metrics: inventory, operating expenses, and throughput. Inventory refers to the money a company invests in all external purchases of goods to sell throughput. Operating expenses refer to the money a company spends within a specified period to convert inventory into throughput, including costs other than materials. Throughput refers to the money generated through sales within a specified period. TOC achieves the goal by applying buffer management, also known as the drum buffer rope approach, in production management. In a DBR-BM model, the drum is a bottleneck that constrains the entire system's capacity. The available capacity of a critical chain resource decides the maximum material flow, setting the working pace for the whole system. The buffer stock maintained before the bottleneck ensures we can fully utilize the CCR's resources to achieve maximum throughput. Alternatively, a buffer could be a work in progress between the subassembly line and the main assembly line or a stock of finished goods. So, a buffer protects a CCR from being underutilized. The rope defines when to release work or material into the system and its sequence, which prevents excess VIP. This schematic shows what a typical DBR-BM system looks like. Last, I would like to wrap up today's session with the 9 TOC principles for production scheduling. The first one: don't balance production capacity. Balance material flow instead. It is impossible to balance the production capacity. We have to adapt to the changing demand by synchronizing other processes with the bottleneck. The second one: the utilization rate of a non-bottleneck resource is not determined solely by its capacity but rather by the system's constraints. This means that non-bottlenecks won't achieve a 100% utilization rate. The third one: the utilization of resources and their activation are not the same thing. The fourth one: the loss of 1 hour at the bottleneck is equivalent to 1 hour lost for the entire system because the bottleneck's capacity constrains the whole system's capacity. The fifth one: working time saved on non-bottleneck processes is meaningless because it will not impact the throughput of the entire system. The sixth one: the bottleneck constrains the current period inventory. If supply is greater than demand, the market is the bottleneck. Any stock levels higher than the stock requested by the bottleneck will be wasted. The seventh one: the transfer batch size could be more than one piece, and in most cases, it should not be equal to the processing batch size. The larger the batch size going through a bottleneck is, the higher utilization the bottleneck will achieve. However, the transportation batch size depends on the processing batch size at non-bottlenecks. The eighth one: the processing batch size is not constant, it should vary over time. As I mentioned in the last principle, the processing batch size should vary according to the station's characteristics. The last one, the master production schedule, is based on the constraints, determining which products should be produced and in what quantities. Please leave your comment if you have any questions about today's topic, particularly about the 9 principles. I will post another video to answer the questions you raised. In the upcoming video, I will talk about the TOC's thinking process, the 5-step approach, and the comparison of Lean and TOC. Thanks for watching, and see you next time.